In the previous video, we saw how we could add web servers to handle more traffic and a lot of users. In this video, let's scale up our database layer. I hope you're ready. Let's get started. Welcome back, engineers. In this video, we're going to look at our data layer and we'll see how we can scale it up using vertical scaling and horizontal scaling. Let's get started. So previously, when we talked about adding a load balancer to our web servers, it looks something like this, right? So there was a load balancer layer and then we added some web servers, and we could add any number of web servers here because each web server is quite independent of each other, right? So if one web server would go down, the other web server is not really affected. Maybe there's some more traffic coming towards it and that's it. There's not really a coupling or any cross dependency between the servers, right? But when it comes to database, it's not so simple. So in this scenario, what would the database look like? It would look like something like this. So there are multiple web servers, but they are all pointed to a single database as of now, right? And because everybody is pointing to it, we know that there's a lot of high incoming traffic. And just like a web server, a database is also a server, right? It's a computer with a box of RAM and CPU and everything. Right, so even this server, it is having some limits. There's only so much it can handle, right? So when we are pushing in more traffic towards it, we can either face performance issues or slowness in response, or we could just see it fill up and we will end up with low storage, right? So we need to think about how to scale it up. So one way to do that is add more storage and add more RAM or CPU to improve its performance and so on. Right, so that part is called vertical scaling. So we already know how to do that. It's a box anyway, so we just add stuff to it. But beyond a point, we cannot add stuff to it, and there are limitations towards vertical scaling, right? So as long as you can do vertical scaling, and if it is surpassing the requirements of your application, maybe it is able to handle all the traffic that you probably need for your entire life cycle of the application, it's good to do vertical scaling. It looks complex and it does the job, right? But beyond the point, we need to think about distributing this across multiple servers and share the load. So how are we going to do it? So just like in the web tier where we added multiple web servers, we can add the same thing to the database layer. We can add multiple database servers. So we can have database 1, database 2, database 3, and so on. And the web servers can talk to the respective database servers, right? But it's not so simple because database servers are not so independent because there's data involved and there are going to be read operations, write operations, update operations on top of it. And if you just put multiple servers, you're basically creating copies of data everywhere and they all need to be kept in sync. So for every write operation, you need to write it to multiple servers and keep copies of them. And you just need to think of ways to keep it synchronized. This could work, but it's just a lot of duplication of data and redundancy of data. And we need to remember that with every added server, there is additional cost, right? And you would want all the configuration to be same across all servers. So that will just shoot up the cost. So that's something to think about when making such decisions. So this type of dividing of database into multiple database servers is called horizontal scaling. And now we're going to talk about a concept called database sharding, which helps with the bottlenecks that I just discussed. Let's see how sharding looks like. So instead of adding just database servers 1, 2, 3, we are going to take 3 servers, but we're not going to make copies of the same data everywhere. Instead, we are going to split our data and put them into multiple servers. So let's say we have a large user table. So how we can do this is 1/3 of these users will be in database shard 1, 1/3, the second third of the users will be in database shard 2, and the last third will be in database shard 3. This way, our data is split into multiple servers. And by doing this, I'm able to split the data load between different servers. And the web servers can have some logic in place to decide where they might find the data that they're looking for. So let's say they want to look up for the users in the first third. So web server can talk to database shard 1, and maybe web server 2 needs a combination of second third and the third third. So it can make 2 database calls like this and collate the information and send it back. right? So that way we are able to distribute the data among different servers, and we don't really need to keep copies of them. So there are a lot of different ways to do this sharding, the splitting up of data. So let's see how that actually looks like. So let's say we are doing this on a user table, and we have some fields like this. Maybe we have the ID field, for example, and there are 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and so there are users piling up like this. So one way to do this is to choose a shard key, and in this case that shard key can be this ID column. So the ID field can become the shard key, and we're going to use this to split up our data. So one way to do this is just use a hash function. So if we have 3 data servers like this, and we can just do ID modulo the number of servers. So in this case 3. So whatever ID is coming in, we can pass it through this hash function and we'll get some result. For example, if we are passing the ID 4, it goes through this and the result would be 1, and this record can go into the second server, which is server 1, right, and so on. So if you want to go with the ID 9, this results in the modulo 0, and we can go it here, right? So this way we can do sharding. So the data can be split like this. And another way to do this is maybe use a region. Maybe users have region specified inside them. So we can choose something like all European users can go into one server, or Asian users can go into another server, and so on. So we can do region-based splitting or ID-based splitting, or maybe we can do range-based splitting. Like for example, the usernames start with some alphabet, right? So we can say that A to F can go into one server, and I to maybe P can go into the second server, and so on, right? So there are a lot of different ways to do this, but the idea is to just split the data amongst multiple servers so that the load is distributed among different servers, right? So this is called sharding. So we've talked about the vertical scaling, horizontal scaling, and we have seen how horizontal scaling can be done by just adding servers and keeping copies of it, but that's not really effective and cost friendly. So we can use the concept of sharding to do the data splitting and keep our servers distributed and more effective in use in general, right? And what about the web servers? So how do they talk to these shards, right? So one of the configurations can be that each web server is exposed to all the shards, right? So they have some inbuilt logic to determine which shard has what type of data, and they can query the respective shard and get the data and make use of them. So if they need data from multiple shards, they will ask subqueries to the multiple shards and get them, and finally compile them and collate them, aggregate them, whatever they want to do, and then return back the response, right? So that is one configuration. Another configuration could be that the modern databases have a router in between. So the database shards are not exposed to them at all. So there's a router in between which is taking care of doing the same activity. So the web servers are not exposed to the shards, they're just exposed to the router in between, and the router can take care of doing the subquery splitting and aggregating and communicating with all these shards and so on, right? So that way the web server layer can be independent, and they just need to talk to one endpoint or one router node, right? So these are two ways of handling it, right? So that is all about horizontal scaling and sharding. Now let's talk about rebalancing. So rebalancing is nothing but adding or removing a database shard. So what happens if I add one more shard like this? So we cannot just add a shard, but we also need to think about how the shard will be used. So will the data be added to this shard? How will the web servers get to know about this shard? How will the web servers include in their logic without having to reboot, so that now they can ask questions to this database shard for? So maybe the router can take care of this in the router topology. And what we can do is we can now distribute the data amongst 4 servers. So just like this example, instead of doing mod 3, we can do mod 4 and now distribute the data. So this rebalancing activity is actually not so simple because these servers are online and they are giving out the respective data to the web servers, and they all need to coordinate and do the splitting of data into database shard 4. And then once everything is split up evenly among all of them, they can go back to whatever they were doing. So this type of rebalancing activity needs to happen in the background so that none of the shards are disturbed and the web servers are not disturbed, so that data keeps flowing and this rebalancing activity takes place in the background, right? And once the activity is completed, there can be some mechanism to notify the web servers, maybe through some event channel or using some notification system, right? And web servers can update their logic to include the new shard and they can route their queries. Or in the router scenario, the router can take care of all this and nothing is exposed to the web servers, right? So that way we can handle rebalancing. And the same thing happens when a shard needs to be removed. Maybe for some reason we want to remove this shard. So we cannot just delete this shard because we're going to lose data. So we're going to have to move the data, whatever is available, into the remaining database shards so that the data is not lost and the web servers are not affected, right? Basically, the users are not affected, right? So that way we can handle rebalancing. So in this video, we talked about the database layer, we looked at vertical scaling, and we've talked about horizontal scaling. We've looked at sharding and rebalancing, right? So at this point of time, you might be wondering, okay, we have split up one table into multiple servers, but what about the entire database? Database could have hundreds of tables, right? There can be many tables, T1, T2, T3, and some tables may be small, some tables may be massive, some tables may be of medium size, right? So do we need to do this sharding and rebalancing for every table? The answer is it will be an overkill to do that. So we don't need to do that for every little table because maybe some table has just 2 records. Maybe it's holding the type of genders and maybe there are records of male and female, maybe some more, but it will not cross beyond 10 maybe, right? So we don't need to talk about sharding and rebalancing and all that for these type of tables because that will just be an overkill because we could just put them in cache for that matter, right? So how do we decide if we need to do this sharding or not? So for that, there is a simple trick that we can use like this. Shard what needs to scale, co-locate what needs to be joined or accessed together, and replicate what's mostly read-only. So let's analyze the statement. Shard what needs to scale, which means that if a table is scaling up to a large extent and we are talking a large number of users or maybe orders or maybe comments and posts and so on, right? So these type of tables, they keep on increasing as the users grow. So these type of tables, let's shard them. Let's put them into multiple data servers and add some sharding techniques and split them and distribute them evenly. So good. Second thing is co-locate what needs to be joined or accessed together. So for every query, if I have to go to this shard to get something and then I go to some other database to get into table 2 and come back, if I'm doing that continuously, that might be less efficient. So I can use this database server to put data that is closely related to each other, right? So all the relevant data can go into one server and when the query comes in, only this server can answer the query and give back the answer, right? So that way I'm able to reduce the number of calls between databases. And the third thing is replicate what's mostly read-only. For example, maybe we have a country list. So country list is not something that will change frequently and mostly it's read-only, right? Nobody is going to make a lot of updates or inserts into the countries because we are not getting new countries every day. So these type of tables, maybe we can just simply duplicate them amongst multiple servers. So country table can go into each of them. So there are multiple copies of it basically, and it adds some redundancy. But if it is in effect making the query more efficient, because we're not having to go to multiple servers to get the country information. Let's do that. Let's make that trade-off, right? So that our performance is faster, right? So this is the general, best practice, you can say, to think about sharding. So whatever is scaling up passively, think about splitting that data into multiple servers through sharding techniques, and put whatever is closely related and access together. So understand your query patterns and put everything together. And whatever is mostly read-only, just make copies of it, and keep your databases happy and very efficient and performant, right? So we covered a lot in this video. We talked about scaling, rebalancing, sharding, and everything, and we also looked upon when to shard, right? That's all for this video, guys. If you have any questions, definitely let me know. I will quickly see you in the next video. Thank you so much for watching. Do leave a like if you found something helpful in this video. Thank you so much for watching. I'll see you in the next one. Cheers.